We frequently imagine the end of the Earth as being engulfed by the Sun during its red giant phase. But that is not the only possible end for Earth. There are 3 other ways for Earth to die or survive a fiery death. Follow me to find out more. Hello everyone, welcome back to Zeey. Subscribe to our channel and ring the bell to receive our daily videos. The ambiguity surrounding the red giant phase is first and foremost. While most models predict that Earth will be engulfed, there is a chance that it will not, in which case Earth may survive first as a molten cinder world orbiting very close to the surface of the red giant sun, or as a frozen former cinder world forever orbiting a dead white dwarf sun. We are the next possibility. It is physically possible for a planet to migrate through time to follow the sun's increasing habitable zone. Because to the sun's rising luminosity, this will have to happen far sooner than the red giant phase, which will begin in a few hundred million years. The migration would be accomplished through many repeated passes of a gravitational source, such as a series of asteroids, to nudge Earth's orbit further out to compensate, and eventually during the red giant phase itself into at least near Jupiter's orbit, if not further depending on the sun's uncertainties. However, this only buys time, since after the sun exits the red giant phase, it will become a white dwarf, causing the solar system to dramatically cool. There may be no way to avoid a surface freeze at that point, though the Earth will still retain some geothermal energy. One estimate on how long it will take the Earth's core to cool puts it on the order of 91 billion years from now, long after the sun becomes a white dwarf. Here it appears more possible that at that point in the distant future, humanity will have colonized other nearby star systems, even if they lack suitable planets. There are always habitats such as O'Neill cylinders, and it has been proposed that space has advantages over planets. All you need are raw materials, which can be obtained from asteroids, and you can base all of your manufacturing and agriculture on habitats. That's a somewhat overlooked potential solution to the Fermi paradox, which states that all alien civilizations prefer space over their home planets and that we don't stand a chance of detecting a group of rotating habitats at great interstellar distances, especially if they don't emit strongly radio or pass in front of their star from our perspective. Whether we use passing stars to establish planetary colonies, or simply habitats if there aren't suitable worlds to terraform if raw materials are available or transported from our dying star system, or we hollow out an asteroid and turn it into a generational ship that we can use to cross to a nearby star system. That may be simpler than migrating Earth, while knowing that there will be a hard end no matter what when the sun reaches its white dwarf stalemate. There are 2 other issues with moving the Earth around the solar system. The first is the possibility that you would overestimate the size of an asteroid or comet, which would need to be around 100 kilometers wide to be effective. That's nearly certainly larger than the asteroid that wiped out the dinosaurs, so if one of the gravity-assist asteroids mistakenly collided with Earth, we'd almost certainly become extinct. But that isn't the only danger. The second scenario is significantly worse. With so much gravitational shifting going on, there's a danger we'll lose the moon entirely. That is one of the worst things that might happen to humankind, because not only would the Earth's climate be significantly affected, possibly fatally so for us, but it would also have a significant impact on the Earth's rotation and eventually its orientation. However, something more practicable utilizing this technology may be in the cards much sooner than the end of the solar system as we know it. This would be for Mars to migrate. There is no significant moon to lose here, and it doesn't really matter if a deserted Mars is accidentally hit by an asteroid. If it's only sparsely populated, it may be reasonably simple to evaluate that population once we realize we miscalculated on the asteroids. This would provide the benefit of a more habitable Mars, but terraforming would appear to be more difficult than previously anticipated. This derives from recent research on how much carbon dioxide Mars has stored in its polar caps and other areas. The simplest method of terraforming Mars would be to melt the carbon dioxide and water ice and start a greenhouse effect. Unfortunately, we now know that Mars lacks sufficient carbon dioxide to do so. This means that any terraforming we conduct on Mars will require resources from outside the planet, such as massive volumes of CFCs or other heavy greenhouse gases, which may be infeasible in the long run. Still, it's possible that Mars has undiscovered subterranean quantities of carbon dioxide that could assist compensate, but there are other issues to consider. One issue is that we don't know how much nitrogen Mars has, and we'll need it to do anything Earth-like. However, we don't see much, but there is also the option of deliberately bombarding Mars with comets, which may allow for long-term terraforming, though clearly it would not be safe to live there for an extended period of time until the bombardment was completed. But there is another type of position that Earth could find itself in before the end of the solar system that could dramatically modify the equation and our personal equation. This relates to stellar encounters, which I discussed in a recent video in which stellar encounters occur relatively frequently across geologic time, providing a perfect opportunity to colonize another star system during one of these encounters without having to travel vast distances across interstellar space. However, there is a chance that this will go wrong. There isn't much of a possibility that any of the planets will be influenced during a star encounter because the encounters, while they happen, the last one was just 70,000 years ago, tend to be remote out in the Oort cloud and have generated only small effects on the planet's orbits. However, in some cases, this may not be the case, and if a large enough star passed close enough and repeatedly perturbed Earth, there is a small but not insignificant chance that Earth could achieve the Sun's escape velocity and be ejected long before the Sun's red giant phase. Indeed, if the appropriate circumstances are there, it could happen within the next few million years. There are no known future stellar contexts that could achieve this at the moment, but the further out you try to project here, the more difficult it is to determine exactly what will happen in stellar encounters, or even which ones will occur. So we're safe for the time being, but it could happen in the far future, but it's unlikely. However, the chances are fewer than 1 in 100,000, implying that this does occasionally happen to an Earth-like, and maybe populated, planet out there in space. So what if Earth was ejected from the solar system by a passing star? It would become a rogue planet right before our eyes, and there would almost certainly be nothing we could do about it, even if we tried to gravitationally migrate it. There are various possibilities here. Earth may get extremely unfortunate and collide with one of the gas giants, but if that happens, it will be ejected from the solar system. If we were still alive, this would not be a quick process, but rather a terrible long-term one filled with climate-related changes and instability. However, society would continue for a little longer, and we could prepare some basic surviving form of civilization to endure indefinitely using geothermal energy. This would not be a vast population. The days of Earth supporting billions of people would be over, because we are all dependent on the sun in some way. However, a core population may survive even when the Earth's surface freezes solid and a perpetual state of night takes control. However, as long as geothermal energy exists on this planet, life could continue as an interstellar analog of an ice shell moon, with hot spots and oceanic vents providing an environment for at least microbial life to survive, and human technology allowing us to maintain a surface presence while living more like a true space colony than a species native to this world. At the same time, there is a ray of hope. Any spectacular meeting will be known of long before it occurs, allowing you to plan ahead of time. Preparing the Earth and relocating the majority of the population to space habitats could be a successful mitigation option. Those left behind may not have a planet to dwell on, but they would benefit from abundant solar energy as well as the ability to shift homes outward far more easily than a planet when the sun's luminosity increases. That's an intriguing scenario in and of itself, with hundreds of cylinders, each with thousands or more people living on it, slowly but steadily migrating outward over time, but with a brave group of volunteers opting to stay on Spaceship Earth when it truly becomes a spaceship and heads out into space as a rogue planet. But there's another level to it. Even if we're long gone by the time an ejection of Earth is possible, the story may not finish with Earth wandering the galaxy indefinitely. There is a non-zero probability, very small, like 1 in 300 billion, that the rogue planet Earth will be grabbed by an altogether new star system after a long period of wandering. If life survived, even microbiological life, it could thrive, adapt, and live considerably longer than it would have in its original solar system. The odds are against this scenario, as Earth will most likely be destroyed by the Sun, but it's fun to imagine an Earth living a new life as a rogue planet or even a member of another star system entirely, and if it's a red dwarf, it could be in that situation for potentially trillions of years orbiting a living star. That would be a weird state of affairs, but I'll leave you with one last thought. The odds of being ejected by a passing star are nearing 1 in 15 to 100,000, and the odds of being grabbed by another star are considerably worse, but the odds aren't that horrible when you consider the entire observable universe. We know Earth-like planets exist, and we also know life can exist in the universe, but we don't know how likely it is. However, among the 1 billion trillion stars in the observable universe, this type of ejection scenario has most likely occurred to someone, sometime, or at least a microbe planet. At the very least, the ejection capture is less likely. It must occur under very particular unusual circumstances. In our circumstance, a rogue planet would be extremely improbable to be captured in a solar orbit around the Sun, if not impossible with Jupiter involved, but it's an intriguing take on the dynamics that could exist in the universe. Panspermia, indeed, but this time not just a rock, but a whole ecosystem might be transplanted to another galaxy. Alright guys, this video ends here. Thank you for watching, and we'll see you in the next video where we'll look at even more exciting events in our world. Don't forget to like and subscribe to our channel to remain up to date on our latest videos and most fascinating topics.